to introduce Dan Rosanova, who's a Principal Program Manager at Microsoft. And Dan's going to be talking about the Reactive Cloud Azure Event Grid. Over to you, Dan.
Thank you. I think this is my 5th time here. Today is my 1491st day at Microsoft, so a little anniversary for me. And in the past, I used to talk about BizTalk here, but I will not today. And I'm actually going to change topic a little bit to follow up from Clemens' session. We're going to talk a little bit about eventing and streaming with Azure and sort of what these are and what we think about them. So this won't just be a grid talk. But when we look at what's happening in the cloud, in the world actually, like what's going on and why is there so much data right now, some stats out here that are pretty impressive are that we actually, 10 days or so ago, a week ago, we passed 2 trillion requests per day in Azure Event Hubs globally in the public cloud. And if you look at some of these other stats, things like there are 269 billion emails sent per day. I'm not sure how many of those are real compared to spam, but there's a lot. And then one I like a lot actually is the 60 billion gigabytes of data created every single day. So 60 billion gigabytes. That's a huge amount of data. So these are just some kind of stats to give you an idea of what's going on. Only one of these is in our cloud, but in the world in general, and why is messaging and eventing and streaming such a big deal now. If we look at how big data came to be, it really is the confluence or the joining of these things, of the fact that there's a lot of data in the world being created every day, that it covers a lot of different types, so that the information is structured sometimes and sometimes it's not. Some of it are streams, and I'll talk a little bit more about what I mean by streams. Some of it are messages, which I think Clemens did a very good job describing. Some of them are files. Like who in here is doing integration with files today? Anyone? Okay, I am, so I would guess most people are. Some of the information, some of that 60 billion gigabytes a day is immediately useful, and some of it's not. Some of it needs some work, some refinement to be useful, and some of it just never will be useful. And figuring out what of that is important is a big task that you'll be facing as people doing integration. And when you look at the tools that people are using to do integration, this is a pretty diverse set of tools. Just some I put on this slide just for fun this morning. I actually wasn't going to put BizTalk on here, and now I know I did. So I usually put all sorts of fun pictures of BizTalk in my presentations, but I'm not going to this year. So just a few of these that are interesting, though, is that who is using any of these to do integration today? Who's using BizTalk? Anyone using other things in Azure? Okay, yeah. Anyone using Kafka? Okay, good. Not good, but we'll see. So even within Azure, we have a lot of tools to do integration with. And I just rattled these ones off in my hotel room last night about tools I've used in Azure, for better or worse, to do integration with. And we'll talk about some of these and what they're good for integration. So I would imagine these are some of the tools that you're probably looking at in Azure as well. And then you look at this list, and there's more than this. This is just a short list. And the first thing you're going to think to yourself is, well, which one's the right tool, right? How do I know which is the right one? Which was a challenge my dog faced all the time. These are his toys. So when we look at the segmentation of messaging in the cloud market, this is a slide that I usually don't show publicly, which talks about simple queuing, which would be storage queues, eventing and pub sub, which would be grid, data streaming, which would be event hubs, and enterprise messaging, which would be service bus. We definitely see these as different. They are designed for a different purpose. There are things you care about for each of these and things you don't care about, or things you're willing to give up to get that. So event hubs is a great example. People really want something that they're thinking in terms of streams. They're thinking in terms of megabytes or gigabytes of data. They're not thinking in terms of individual messages usually. So they're willing to give up some things for that, like server-side cursor or once and only once. Because those are trade-offs you give. There's no one super tool here. And when I look at how these are broken down into sort of the ecosystem that they live in, I see serverless, big data, and enterprise solutions really sort of driving these. And I think us adding Kafka to Event Hubs made it much more clear for what it was. Event Hubs is pretty much Kafka. We looked at Kafka and hosting Kafka, and we went and made Event Hubs 4 or 5 years ago to have an alternative to trying to make Kafka work as a multi-tenant cloud platform. But we were able to kind of make that fit in. And when you look at something like Event Hubs and call it Kafka, it makes much more sense of why we have IoT Hub and Event Hub, because they're really for different things. And so you do get people that ask, though, which one is the right tool? Or which one's the best tool? That's my favorite one, especially because we manage all of these. Every new service, people think, oh, should I stop using Service Bus because Grid is out now? Maybe, but it's like this. So which of these is the best to eat with? That's very much a context-driven question, right? I mean, I might have my favorite, or maybe my one I go to by default. But sometimes it's really easy to decide what's the best tool to use. This is a case where it's pretty easy to know to use the spoon. Sometimes it's not necessarily as clear. You might need more than one tool for this. Sometimes it's just confusing. And you just don't know, like, what is that? And sometimes you do need more than one tool. And then there are other times when you need a specialized tool that you weren't really planning on. And then you get to a place, though, where you still get people that say, I just want one tool, make my life easy. In reality, we're not making your life easy when we combine tools. We're making your life more difficult. Has anyone tried to eat a steak with a spork? I would challenge anyone to try that. So the spork is a suboptimal tool that's combining two very well-designed tools in a very poor package. So now I want to talk a little bit about some of these tools, and the two I'm going to talk about today are Event Grid and Event Hub in some detail. So looking at Grid, some of this you saw from Clemens already. The whole idea here is that it's this high-level pub-sub sort of thing. And I shouldn't say sort of thing, it's this high-level pub-sub platform that exists all across Azure. We designed it really to serve the serverless space, so it's really actually hard to make serverless work without some sort of eventing infrastructure behind it. And one of our team members, a VP on Azure, used to say that functions doesn't function without Grid. And it's your execution, like your function piece, really is like in code. It's the on button click. And you need some way to fire that on button click. And this is what Grid is meant to do in the serverless landscape. In the ops automation landscape, it's really designed for something else, which is similar. It's reacting to events, but it's a different type of reacting to events. And that's really for more people who are responsible for operations of systems and platforms. They want to be notified about changes. They want to be notified about deployments, about scale events, about all sorts of things. So you might want to tag VMs as they're created and just get notifications anytime a VM is created. You might want to do that for like storage accounts and run your own policies and rules to say, does this meet my requirements of where I expect my storage to be? And does it have the features like encryption turned on that I expect it to have? And then the last one is really third-party integration. And this is a place where you can extend your applications to actually raise their own events and then do eventing between applications. So if you have something like CRM and you want to fire things in Azure based on your CRM or even from on-prem systems. At a very high level, Grid is pretty simple. There are 5 concepts in total. 5 is actually too much. I should probably cut this down to 3 or 4. As a former consultant, pretty much every slide I do has between 2 and 5 bullet points on it internally at Microsoft, and the right answer is always 3. So the first concept is what happened. That's the event, what happened. So a file was created in storage. The second is the publisher involved. So storage is that publisher. Where did this take place? Well, the event took place in Azure Storage. Next is the topic, which usually in Grid you only sort of see by proxy. You'll see what I mean in a second. So that is where publishers kind of express or push their events. And the fourth is subscriptions. How do you express your intent to receive events or your interest in specific events? That's with a subscription. And the fifth are the handlers. Where do those events go? So if we back up a little bit and look at an actual event, what does an event look like? It looks like this. Is anyone familiar with Event Grid? Has anyone heard of it before? That should be every hand because Clemens mentioned it. But anyone using it? Yeah, okay. So this is an event. Let's see if you can see that okay on that screen. Yeah, it's okay. The pieces of interest on here are really topic, subject, and event type. That is how you're expressing your intent, something you're interested in. You say, I'm interested in things from this topic and this event type, and you can do prefix matching on the subject. Any event that comes, the data payload, the lower part, is actually driven by that event type in the top. So what's in that data JSON changes, and you'll notice this is a storage event. So that topic is actually the resource manager path to a storage account in Azure. The subject is the path within that storage account to a specific blob, and this is a blob created event. And then the data tells you where this blob was created. There's a URL for it. It tells you which API created it. It tells you the content length and some other interesting stuff about it. So this is really metadata, about the storage event that happened. So this is the storage event, not the storage file. When you look at core concepts of events, they are individual, so they are unrelated to each other. Just like in the user interface, there's no order in events in a user interface. That would make a very frustrating experience. They're individually significant. Clemens did a good job talking about this. They happen even if no one is listening. And they are subscriber focused. And this makes Grid different than Service Bus. In Service Bus, the publisher knows quite a bit about the message. They're making choices about lifetime, about what goes in the header to do routing, things like that. And in Grid, the model is turned around completely, and it's all subscriber focused. What we're really trying to do is bring this on-click or event model that was big in C# to the cloud, which is why we use the same icon as Visual Studio did. So a quick hello world of Event Grid, and I almost never live demo. I think in my 5 years doing this, this is the first time I'll live demo anything here. So wish me luck. Yeah. If we look at a storage count, this is an Azure storage count. How does Grid work, right? So Grid is bolted on to everything in Azure, so you really don't have to think about Grid itself. You just have to think about events, which is why we've made this cute little icon on storage counts and quite a few other, all the things that were on the left side of that diagram that you saw for publishers. So if I go into here and I click on events, I can see who is subscribed to the storage count. I can see what's in here. I can see there's one thing subscribed. There's two. There's web app and hybrid connection, which I'll talk about in a second. And now I'm going to open up a CLI. Make sure this thing's actually still working. Cool. And I'm going to go create a subscription on an event. First, I'll show you the CLI tool for Grid. And if I go look at just running that command to get help on the CLI for Grid, I can see some new stuff that's in preview now. You can see this says this extension is in preview. This is stuff we haven't really announced yet completely, but it is here. So some of the things you'll notice is that there's a dead letter endpoint you can specify now. So that's kind of new. Another one is that for your endpoint type, you can see some new stuff like hybrid connection and storage queue. So now you can send your events to a storage queue instead of just an event hub or a webhook. Webhook is the default for Grid. It's always a push model. There's some other fun things in here like TTL, which actually I don't think is supported, but we let you do the max delivery attempts. I think that one's on today. So what I'm going to do now is I have a queue in a storage count, and I'm going to go create a subscription to it for Grid right now. And I put that in a variable to make my life easier so I don't have to cut and paste a bunch of crazy stuff. Oh, that's right, I remember this. And because it's variable, I have to make sure I have a space in here. Okay, so this is going to go create a subscription for that storage queue. You can see in the command here I've got endpoint type equals storage queue, and I put this ARM path of my storage account in there, and then the path to the individual queue that I want to go see. And now it's created, everything's honky-dory, looking nice. And so what I can do now is I can actually come into my storage account that has my event subscriptions on there and go and add a file, upload a file into that blob. Go over here, upload something. I'll just pick one of these files I've been playing with. I don't even know what's in these JSON files, but I'm going to upload them anyway. Overwrite. And so this is uploaded now, and what I can do is go find my queue wherever I put that queue. And here we go. Queue should be over here. And go look at what's in that storage count. So if I come here, oh, not in that storage count. Oops. If I can find which storage count I put that in. You know what? I'll make this easier on all of us, and I'm just going to skip to the next one, which is a WebSocket test. So the same thing that Clemens mentioned is that we can do this all through WebSocket. And the WebSocket thing that he showed is pretty cool. You use this node library. It's very easy. But we can actually host the same stuff through something even more simple than that. And right here, what I'm going to show you is the code for this HTML page that I've got, that I just loaded. This is literally just HTML, JavaScript. So I'm not including any other packages in here. There's nothing I needed to do. There's no node in here. This is just WebSocket. You can see it's WebSocket, new WebSocket, all this fun stuff. And the only interesting thing here is I've got a SAS token that I already pasted into this page. So this page is running here on this browser. There's no server for this. This is literally just running from the file system. And if I hit connect, what I'm doing now is opening a WebSocket to Azure, really to the hybrid connection, the relay. And that is a subscriber today to Grid. And I could actually see that subscriber when I zoomed in a little bit ago. I'm going to upload one more file right now just so we can look at it and watch this happen. And you know what? I want to break this window out so you can see it happen live, because that'll be cooler. I'll move back in time. So if I go find another file that I want to upload, because this is, I mean, I'm behind a firewall here. You know, my computer has a firewall on, so it's not open directly to the internet. And I upload that file, and what I'm going to get here is the push directly to my browser of the event that just happened. And you can see exactly what it was. You can see the name of the file. It was temp2.json. And what's happening is I've plugged this browser directly into Grid. So now I can do things like what we're working on. I don't know if it's shipped yet, is for Visual Studio Code to be able to debug right in your functions on your machine, reacting to what's happening in Grid. So we're getting a pretty rich experience now. Things are coming along pretty well. This is kind of this eventing piece that's pretty cool. And events are interesting because they're things you're reacting to. It's not like, oh, someone placed an order. I guess you could do that. But it's literally someone changed the environment or someone did something in storage some way, or in any other service that's onboarded now. What I want to do real quick is go back to this and then walk through now about, I'll leave some time for questions at the end, but if you have any, just shout them out as we go. I'm not opposed to interruptions. So that's like a hello world from Grid. And now I want to do a quick introduction to event hubs. Who has used event hubs in this room? A few people. Okay, who's heard of event hubs in this room? Okay, it should be everyone now. I've already said it. Sorry, I've taken some cold medicine. And it's starting to kick in, so this will get better and better as we go. So Event Hubs is a service we have that's very similar to Kafka. It's a telemetry, it's a streaming service, really. And that means it's different than a queue, and our intent is different than a queue. I hope there was a hint of that because it was on that previous slide. Wait, that slide like 10 minutes ago had Event Hubs on it. Everyone should have said they've heard of it. So how is a stream different than a queue? A stream is different from a queue, as Clemens mentioned, because it's like a tape. So you think about what a tape is. A tape is something that's recording and moving forward only. It's not like a queue or a stack or something that you're putting stuff in and taking stuff out of. You're just writing to it. You can play this tape over and over again as many times as you want. And so it works a lot like a cassette tape. Does anyone remember cassette tapes? Yeah, okay, cool. I keep waiting for the talk where people are just going to be like, what is that? I came close once. And just like playing back a cassette, playing back a stream is the same way. And that doesn't matter if it's a Kafka stream, an Event Hub stream, or any of the other services out there that give you a partition log or streaming model. When you're playing on a cassette tape, on a tape deck, you can play from anywhere on the tape. You just fast forward and rewind to the point you want on the tape, and then you press play. And you can play it as many times as you like, ignoring the degradation that happens on cassettes. But like a tape, all tapes have a length. And for us, what that means is we're basically looping the tape at the end. So after a day, we're going to overwrite the old data for the most part. So that's how this particular tape works. And to push this analogy a little bit further, when you look at streams, you think about partition consumer is something you'll hear in the Kafka world or in our world, and channels or shards in some other places. A cassette actually has left and right audio channels. That's why you hear music differently from the left side and the right side. And if you listen to like classic rock, you'll hear guitar on one side and drums on the other side, which was really so your stereo, so the record wouldn't skip. But that's a good demonstration of the fact that when you press record, you're recording both these channels, but the data on each channel is actually different. So you have multiple channels, the data is different. We call these partitions in Event Hubs. And on your stereo, the left and right speakers are each playing back one of those channels. So they're playing back different stuff. And that's how partition consumer model works. This is how I like to talk about Event Hubs to some extent. And this is a more architectural view, is that an Event Hub is really just an abstract construct. It's just something that exists there kind of as too many people use the word container now, but I'll just say it's like a high-level construct. When you're sending events to that event hub that has partitions, those partitions go and live on other servers that we own. Those partitions within them have data that's in order, and in a repeatable order, just like the tapes, you can play it over again. So this would be a 4-channel tape instead of the 2-channel tape, which, to bring this analogy full circle, a cassette actually has 4 channels on it because it's got 2 sides and stereo on both. So when I did start my university career in audio engineering, I think so. So when you're sending events to an event hub, you get a choice of protocols. There's actually more you can do here now, like Kafka. And you're just sending data in, and what we're going to do, unless you take steps to tell us otherwise, is we're going to round robin that data across all the partitions. It's going to give you really good throughput. It's going to give you really good availability. If for some reason we're like doing an upgrade on one of those servers that's hosting that partition, and it's not available for a few seconds, which is all it ever is, your sends will just jump to the next server automatically because we know that, and we know what's going through upgrades. So this is the default behavior. You can also do things like use keys to pin data to a specific partition. So I can tag, when I'm sending events, tag an ID on there that's Dan, and then, or my full name would be a better one. And then what's going to happen is we're going to hash that to one of the partitions, and so Dan will always hash to partition 2. And so all Dan's data is in partition 2. And this will be more important when we look at how you read from event hubs. But the thing to know there is then I'm making a dependency on the availability of a specific partition, but I'm getting localization of data for it, which is important when you're reading. Because when you're reading, to receive from this event hub, you need a reader for each channel that you have, for each partition you have. So to read the whole stream, you need to connect to each partition. We give you tools to make that very easy, but fundamentally that's what's happening. Each connection is established, and it's giving a client-side cursor when it connects to say, I want to read from location 0 on partition 1. Or I want to read from location 100 on partition 2. And that's where the tape forwards to and plays forward. So that's how that all works. You can have a lot of readers, so you need one per partition, but then you can have different sets of readers all connected in parallel and independently at different places in the tape. We call these consumer groups, so does Apache Kafka. Coincidence? I think not. Some people would call this model pub/sub. I do not, just because you can listen to the events twice. There's no filtering, there's no broadcast. I don't call this pub/sub, but it is interesting and it's super, super powerful. And thinking about big data streaming or data streaming with event hubs, how does this look? Well, when you think about the data flowing around in your organization, really, much to our chagrin for everyone in this room probably, business people tend to really only care about this side, right? The far side is the presentation in action. Like, how much stuff did I sell yesterday? What was the slowest delivery that I had to make? Where are things breaking down? So this is kind of where the value starts from a business side, and this is where the information starts from like a real world side. Is you have producers of events or of telemetry. They can be applications, they can be devices, they can be servers, all sorts of things. And then what you are doing, your job in integration, is really to make those two ends magically meet together. So no one usually asks what's in the middle unless it breaks. But this is kind of how you design those pipelines, whether on Azure or somewhere else, is that you're doing some form of collection or direct streaming into the cloud. You have to land this data somewhere so that you can process it in the time that you're able to. You do stream processing on it, whether that's fast or slow. It could just be file-based processing, which is very popular, or it could be real-time processing with things like Stream Analytics. And then you're moving to some sort of long-term storage, and then to the presentation in action that makes business people happy. So that's kind of how we put all these pieces together. I'm going to show you real quick hello world in event hubs, how that looks for us. I'll go into the portal over here and go into, surprise, surprise, I'm also going to show you Kafka, which is why this resource group is called Dan's Kafka. So if I go look inside of this resource group, let me close this. I'm going to go take a look at my event hub I have in here. Here we go. Oh, no resources to display. Great. I'll cheat and go through here. Here we go. I have an event hub. This one's in West US. Actually, as of today, unfortunately, it's today North America time. I was hoping to show it today. Kafka is going to be available in Europe as well and in Central US. So that's our big news for today. And if I go look at an event hub I happen to have, here's one. It's pretty easy, plus new in the portal. It's just got a simple topic on here. And if I want to go see how I talk to this thing, I can actually take the connection string off of it from these shared policies. I'm not going to do that right now. And if I look at it in code, so this is code to send to that event hub. This is pretty easy code. It's just creating a client from a connection string, and then it's going to do a for loop and send a bunch of stuff. This happens to be ticker symbols or bid-ask spreads for trading if you're into that sort of thing. And this is pretty easy. Again, I'm not doing any sort of key stuff. It's just literally for and send. On the receive side, we give you this tool, Event Processor Host, that most people, I think in the past at least, use to read from their event hubs. It's really built around this idea of an event processor. You make a class that implements this interface, iEventProcessor, and it gives you 4 methods. The 4 methods are close, open, process errors, and process events. You can guess what those all do. I'm not going to take the time to explain them. But this one, I'm just going to write these out. So if I start this up, just press Start. We need 2 console windows, a consumer and a producer. And you can see my producer sending these events all the way to California. And it is done already. And then in a second, as my consumer starts up, because it's getting leases on these partitions, and you can see that it's reading all of these events now as we speak. And so that is super simple 100-level event hubs running. And if I go now look at something a little more interesting, I can actually see, I guess I'll walk through this first, and then I'll do something more interesting. So the concepts of this are different than a stream. You get that repeatable read, stable order, so you can read the same stream like 4 hours later, and you're going to get the same results if you're doing calculations. That's the idea behind this. They can contain order. You usually partition streams to scale. The idea is not to make them scale up, it's to make them scale out. And they are well suited for structured or unstructured data, and you might actually put events in here. And this is an important point about where streams and events meet, is that you can subscribe to events with a log. So you can actually create an event grid subscription that is an event hub. So you can be logging all the events from like a storage account or from your entire Azure subscription. You can produce events from a stream as well. So if you're reading a stream and you're looking for like changes in the stock stuff, if you're seeing the bid-ask spread invert, that's probably, you could literally make money off that. So you probably want to raise events about that. And a stream processor and complex event processor are 2 different things. They're not exactly the same. So keep those in mind about where these meet and how these services all compose. And the idea here is that you can have a topic like your storage count, and sometimes you want other messaging services to be those subscribers, like storage queues, which is available now, and event hubs, which has been available for quite a while. And your grid messages will go there. Sometimes you want a webhook, which is sort of the default experience for grid and for functions with grid. And sometimes you want a queue, because these things have different semantics. They work different ways. They're really meant to solve different things. And why would you want to do this? Why would you want to change these? A lot of that comes down to scale. There's a really good blog out about using functions to process 100,000 messages a second from event hubs. That's possible because of what event hubs gives you from like scale characteristics of a session-full connection where you can just jam a bunch of events through it. That would be very hard to do with webhooks purely on any platform because you're going to spend a lot of time doing HTTP traffic because webhooks are like request response. If you're doing 100,000 request response webhooks a second, you're spending a lot of CPU on that. And Grid will give you all of these, and you can change your bindings in place without really changing your code. That's a big promise for bindings and functions that we're pretty happy with. I already went over the new Grid features. Forgot to move that one. Stream Analytics, has anyone in this room used Stream Analytics at all? Okay, a couple people. Stream Analytics is a really cool service that I actually have running in the same Azure subscription on this same data. So if I go back and look at Stream Analytics, I have it reading from this event hub. And this job is very simple. Stream Analytics is like a DSL query-like language. I can go see my specific query. I should have changed this because you never want to do a query like this. If you're doing this with Stream Analytics, you're doing something wrong. You really just shouldn't do select star. It's really made for windowing, so you can say, like, give me the top in every 5 minutes, or make an output record whenever the average of this value exceeds some threshold. So it's really meant for more sophisticated stream-based processing rather than just select star type stuff. But you can see here I've got a simple query. There's an input and an output. The input's an event hub, the output's a file. And what this does is it just receives all of the data and writes it into a file. So if I go back to my job and turn it on, I can actually just start writing out stuff to a file. Let's do it, start with now. And if I go look at the actual file that's output, which is in this storage account, here, I'll send some more data by running my app again. And then what we'll be able to do is see stuff being written to the storage account really quickly, which is really the goal of what we want here. So start this up, come back to browser. Now you see why I don't demo live. And so as I refresh this, what I'll see here is that this file will actually get modified here pretty quickly as soon as those new events go through. And that Stream Analytics job is literally just writing the records as they come in. So it's really not doing something useful that I would necessarily care about. But it's cool. The more important things, though, that I want to show you, or more interesting things to me, are how this works with Kafka and our serverless story. So this is a job, a function that's reading from an event hub. When you create functions, you do like plus new on a function. Here, I can just show you this and then cancel out of it. You can pick what your trigger wants, what trigger you want to have. So I can come down here and find the Event Hub trigger and pick what language I want to write stuff against Event Hub in. And that's what I've already done here. Oh, that was not the click I wanted to make. And we'll go look at a very simple function that I have in place here. Open. OK. And for this simple function, I'm going to expand the logs here. And we're going to go run that app one more time and go see it create some data that we will see here. And now what you can see is, yeah, I have event processor host, and that's cool, and I can run console applications to do this stuff, but I can also just have the cloud sitting here reading these events as they come through this event hub. And so let's see, I've got my producer running, and now you can see all of that same data is just flowing into this function, and it's literally this code. And I can do whatever I want in here. I'm just writing to the screen. It's pretty fast, pretty easy, pretty powerful. And then you get some other fun stuff with this as well. So all of these toys are meant to compose together. Good, I got a little bit of time, I think. Is that right? Yeah. And another service I want to show you real quick is Time Series Insights. Has anyone played with that at all? One hand, two, OK, three. So Time Series Insights is a cool service in Azure that's giving you a view over that log that you can search and visualize so you can see what's going on inside of here. So if I actually go here, open up my Explorer for TSI, this thing is just, it took me about, I'd never really used it much before, but it took me about 4 minutes to set up, maybe 3, on cold medicine, so it should be quicker for other people. What that's giving me is you can actually see already that it's showing me live that I've got data that's gone through this. And I can do things from here, like this is not just going to give me visualization, but I can actually go explore these specific events. And what it's doing now is it's enumerating through that stream and showing me what's on here. I can download these things. I can start to split them. So if I had different ticker symbols in here, I could actually split them. Let me add symbol, because you can actually see these are MSFT, which is a new record today. Yes. You could split them then by symbol in here and start exploring the data within here, which is pretty interesting. And now here's where it all gets even more interesting, is we look at what we have right now. Let me make sure I'm actually on track with what I'm supposed to be talking about. Not a lot of people use Kafka in this room. It's actually got a very broad ecosystem. Apache Kafka is a really popular platform in the startup communities. People like it because it's open source and because it's very easy to get started with. But the things I would warn people about are, it's like a lot of open source, it's free. So we're puppies if you adopt them from a shelter, but they're not free to keep. So it's free like a puppy, not like a beer. You have to feed your Kafka. You have to take care of it. But it is cool, and all the cool kids use it. So maybe if you like facial hair and hats and glasses, you might be tempted to use Kafka as well. So we have actually added support into Event Hubs for it. Clemens talked a little bit about that. It's protocol level support. And what this really is that it is running on top of Event Hub. We did not implement Kafka as like a runtime. What we did was we implemented the protocol, which is open. And we've been about open protocols for a long time on this team, since before I joined 1,491 days ago. So what we do is protocol translation. And this gets all of the features that you get with Event Hubs automatically with that. And I'll walk through some of those features right now. Auto-inflate is actually a really cool feature we have for Event Hubs, because this solves probably the first biggest problem we had for event hubs, which was that people would be running with their event hubs. Everything's fine. Our smallest chunk we sell is 1,000 messages a second. That'll let you do 86 million events a day, which will cost you $3.14 US. So if you can do eventing for cheaper and faster and more reliable, please feel free to. But what you get from event hubs was, you got your 1,000 messages a second. That's actually quite a bit. You can run it for a long time and you never really have a problem. And what would happen is our biggest support case would be people would call after like 3 or 4 or 5 months in production and be like, what's going on? I'm getting errors now that I've never gotten before. Something's wrong. And it's that they've only purchased this one throughput unit. So we created a feature that will bump you up one throughput unit at a time automatically instead of throwing errors for you. And this is on by default now. And you can actually tone it down. So you could say, you know what, I don't want to pay too much money. I don't want to pay $60 a day. I only want to pay $30 a day. So I'll stop this at 10 megabytes per second. So you have that sort of control. Or you get other things, and this one actually has it on, so it's probably worth going to look at it. You get other things like capture. Capture is a feature that we built because the whole world is still batch, and this stream thing is a real-time construct, but a lot of the world still runs on batch, and that's just reality. That's just the way it is. I'm sure my last paycheck will be in a batch. I'm sure my death certificate will be probably with a bunch of other people's and probably on an AS400. And so if we go look at, and that doesn't matter how long I live. If we go look at what capture is, it's a feature where we give you a time and size window. You say how many minutes and how many megabytes do you want to close your window on. Give us a storage count, and what we'll do is we'll write the data for that partition to that storage account as it's happening. I have capture running right now on this already, so we can go look at that if we want, actually, since I sent data through here. But what's cool now is you can actually do capture with Kafka. So when you turn on the Kafka feature, you can send through Kafka, and now you can have Kafka writing a stream. Someone else is writing Kafka because they know how to do Kafka, and you can get files that contain the data in that stream. I have Kafka on this event hub, and I want to show you real quick what that actually looks like. Is you can see this is Eclipse. For some of you, this may be a long time since you've seen this. And you can see there's nothing from Microsoft in here. This is literally just, these are the imports for this. It is literally just Java and Kafka. And when this is a sender for Kafka. This looks pretty familiar, right? It looks a lot like what I was doing in C#, actually. The coincidence, I think not. And so the things you have to do here to make this work are you have to tell us where is the server. This happens to be a DNS. And you have to tell us how you're going to authenticate. So these are the properties you need to put in place to make Kafka work. As of Kafka 1.0, you can do these in a config file rather than through code. So if you're running Kafka 1.0 stuff somewhere, you can literally change the config file on the producer or the consumer, and it will work with our Azure Event Hubs for Kafka ecosystems. And so if I go and run this, let me turn on, you know what? Let's go look at that function. That function was cool, and it's already listening. So now if I go back to my friendly function, and I see it load back up, and go look at the output for that function, open the logs, and now I'm going to go start this Kafka producer, and this thing's going to run, and my function's now going to start writing out once Eclipse finally kicks itself to life. It did, so I believe it's already running. And now these are the things coming out of Kafka. So this is not being sent with event hubs, but you saw in this function, this is bound to event hubs. So it's doing protocol translation live for us, and now that works for Kafka. And so too does the output of the capture files, which is pretty cool because, oh, that's why that wasn't working, because that's the wrong storage container. Awesome, great, glad I remembered that now. So if I go look at my streaming stuff, I can go see the capture files that were created for that. And if I go look at the blobs, they will have my capture, and I can see my event hub, I can see the name of the hub, I can see the partitions, and then you get to pick how you want this naming to work. So, you know what, I want to go to today's, not yesterday's. So, oh God, no, really? Oh. Glad Leon's not here, I would have had to say something there. Click back through this, I want the 4th, not the 3rd. Anytime is fine. And if I go look at these individual files, in each of these will be the Avro file that was created for that time. So this one's kind of an empty Avro file. If I do the most recent ones, they'll have data in there from this. And the whole idea here is that what we're trying to do is give you all the tools you need to make this work for you. Event Hubs also has GODR, which I'm not going to show today, but that's a way to do failover that you control between regions. So if you want to fail over between East and West, that works with Kafka in the regions that Kafka is running, works with Event Hubs in any region. So you get recovery time objective built into the service. Real quick, looking at how it is like to migrate from Kafka to Event Hubs for Kafka ecosystems. This is a config file. I mentioned the config file. These were the 3 things you have to change. So it's your Bootstrap server, your SASL mechanism to plane, and your SASL JAS configuration here. And then to set SASL SSL as the piece. You already saw this. And the thing I kind of want to leave you with is when you're thinking about Event Hubs and Event Grid, or any of our messaging stuff, you really have to think about what is the tool you need. You know, don't think about the tools, think about the problem. So, okay, someone gave me soup, I need the spoon. You know, someone's giving you a stream of data, you need Event Hubs. If someone's trying to give you a way to subscribe to events or to be reactive to things, or you're building a serverless thing, you probably need Event Grid to kick that off at least, or to do some sort of orchestration in that. Or start your orchestration. This is a gross oversimplification, but an easy way to think of this is Event Hubs is for fanning your data in. Lots of producers, a few readers, maybe 5, 10, 20 readers of the whole stream max. But you could have thousands or tens of thousands or hundreds of thousands of producers. Grid is the opposite. Your data, like your storage count, you're not going to have 100,000 storage counts. I don't think. I'd be really surprised. But you might have 100,000 listeners for one storage count. So that is the designs are 2 separate things. Think about that. And remember, there is no spoon. Oh, there you go. Yes, there is no spoon. That's your Zen moment for the day, I hope. And I will be around the rest of the week for any questions you have. We have like 2 minutes for Q&A, if anyone wants any now. This is Seamus. He goes in all my presentations. So that's him at the beach. Thank you very much. And please go and try these toys if you haven't. Event Hubs is actually really popular for integration. You'd be surprised, especially with that capture feature. It works really well for replacing these sort of SSIS type things that people are doing, especially if they're doing them with modern applications that are going to be using like Log4j or Log4net. And you can pipe those appenders right to Event Hubs or to Kafka. Thank you.